Hi, my name is Vinay, and with this video I will show you how to use Case Slicer Pro software to generate the slicing files to print over a 3D printer. So this is how the GUI looks like of a case slicer. On the bottom side there are the setting panels, and you can go through various settings like style, support, extruder mapping, printer settings, and even you can even change the material settings in your software. As of now, I would be demonstrating a file generation for using an ABS material and, if possible, HIPS also. So you can open your model file, which is maybe in STL. You just open the STL file. If there are any mistakes, that is the errors in the file, you can fix up the mistakes and load the model. So this is how you see the model. The dimensions are visible over here. If you just hover your mouse over this image shown on the right hand side, you can see the dimensions shown. The slicing is dependent on what kind of style you want to fix up. So by default we have set the software for different three styles: fine, normal and super fine. So if I select the normal settings, the layer thickness is set to 0.25 millimeters, that is 250 microns. The infill is being set to 20%, which you can change by just scrolling the button. So if I set this infill to 50% and slice it, so within few seconds he sliced the model, and it shows that how much amount of time would be required to print this model, which is approximately 1 hour 40 minutes, and the amount of material used is around 7.76 centimeter cube. So you can see this how the print would take place. You can even select to show the model plus path. Now in this you can see the layer by layer construction of the geometry. So on the right hand side there is a scroller, so you have to just scroll from bottom layer to the topmost layer. So when you start from the bottom side, so you can see the print happens, but as you can see the center part is being printed simultaneously and there is no support from the ground. So that means this would be printed in air, and that will not give accurate results because that would be an hanging material and would cause distortion in the print model. The rest of the layers comes good because they go layer by layer and they are being supported by the bottom geometry. Now as this is being printed in air, so it's better to give a support material. So I can go to the support tab and increase the kind of support I want to have. So this is coarse support or rough or medium, or even you can have dense support. So for example, I've selected medium support and slice it again. So in this case he will be using the second extruder for the support, because in the extruder mapping I have told him that the interface and the support extruder is the second extruder, which is an HIPS material over here. So now you can see that the time has increased from 1 hour 40 minutes to 2 hours 11 minutes. That means he would be using some extra support material to print this model. So when you now scroll the path, so there you can see some white material deposited. So that is a support material who would be supporting your below in air or the hanging geometry. So you can see the green lines, these are the support infill. So that is a 50% set to now. The light blue and the pink color are shown the travel path of the nozzle. Now if I select the fine settings, so in this case you can see the layer thickness has been set to 0.2 millimeter, so that is 200 microns. So that will give me more surface, better surface finish, and even it can print better complex geometries. So now in this case you can see the print time shoots up to 4 hours 41 minutes, which is approximately double of the previous one. So it depends the kind of geometry you have and the kind of precise print results you wish to have. So here you can see that layer by layer construction is coming very nice. Okay, you can see the support material, the white one, and the green ones are the infills. Once it is being ensured that the slicing has been done correctly, you can save the file in the same folder and it will generate the print file, that is the Gcode, and will store in that directory. Now you have to use the repeater software to print it further. To use the repeater software, you have to start the other software which is called as repeater host and load the file which you have generated from that directory. So just let me browse through. Yeah. So here you can see the rim for tire Gcode. Yeah. So here you can see you see some light blue and the dark blue colors in the geometry. So light blue is the travel path of the extruder and the dark blue is the actual deposition of the material. So you can ask him to hide the traveling. Yeah, so now this shows better construction of this. At the bottom side you can see even the deposition of the second layer material, which is the hips. There. So that is your support material, this one, the green one. Yeah. So in the repeater you have to just save the job. So this will convert the G code into a .gco file, which is a more lower level firmware level code which the printers accept. So just save in the binary format and save the file, and you can rename the file as whatever you like and save the file. Now you have to load this tire.gco file in the printer's SD card and print it from there. Thank you for watching.